Hi, welcome to this Open Security Summit in October 2023. And I'm here with Nathan, and Mario is going to join in for a bit, right? And we're going to be talking about Kubernetes clusters network security, or I guess Kubernetes security, right? Because that's really the key topic. So, Nathan, why don't you kick us off?
So I guess the question becomes, like, as we look at this whole thing, first of all, hey, I'm Nate. Secondly, my views are my own, yada, 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 not the company, all of that. But today, as we speak about this, the real question becomes kind of this discussion about what is security and what is network security in Kubernetes, and what can you expect? What should you expect? What should you hope for? I mean, when you asked me to do this, Dennis, I mean, like, honestly, I kind of sat back and went, okay. Like, I just did a talk about KubeShark. We can totally talk about KubeShark. The company I'm working for, Korsha, has a new product called Cast, which is kind of an extension of KubeShark, and there are new things that you can do there.
Mm-hmm.
There are a handful of stuff on, like, open source projects we can look at online. But when it comes to actual security, I mean, what do you guys think? It feels like the network security of days gone by, when I used to play with switches and hubs and routers and, like, coax connections. All of that's gone. And I think we end up with this really interesting logical setup that frankly hasn't existed before.
So one of the things I've done, which I still feel it worked quite spectacularly, was to build a large number of very small clusters.
Mm-hmm.
And I arrived there from a point of view of having, the least amount of moving parts by having lots of problems with scaling, right? Because when and this was a project, where I had to go from small amount to file spring process to large amount of files. And there's this interesting spot where you start to fight Kubernetes, right?
Mm-hmm.
You start to fight the system. And then it's kind of like this thing where eventually everything starts to break, right? Because you either struggle with the backplane, you struggle with the network, you struggle with the ability to start new pods. It's almost become, in a weird way, I felt this anti-pattern that suddenly the more stable things become, the more locked things become, the more solid they were. But I was like, hold on, the whole point of Kubernetes is dynamic load, right? It's go up, go down, go up or down. So I started to go into this mode of okay, what's the smallest cluster that I can do? Because in a way, the irony is that it's almost like you go, okay, you need multi-nodes, you need multiple big clusters because you get resilience. And I start saying, yeah, but I'm actually losing quite a lot. So I start going, okay, so I got to the point where we created one node. And it was one node cluster that had one basically deployment. We had very small number of pods that were almost per application. And then the thing that was really interesting is that from a design point of view, it really forced you to think where do you store things, what's persistent, what's not persistent. There was tons of problems that existed. It's like the HS2. I don't know if you're in the UK or not. Are you in the UK?
No, I'm not.
Yeah, there's a big shit show here because we had this massive megalomania project of building one thing super big, right? And then of course, it blew up. Costs got bigger and bigger and bigger because the complexity got bigger and bigger and bigger with the project, right? So when I was basically thinking about this, was like small clusters actually have lots of advantages because you can scale up and down very easily. The only question, there's a bit of state. But in a weird way, I like that problem because it forced me to take state away for sometimes parts of the cluster, which actually made the cluster itself, disposable. Because it's almost like, think about it, we take Kubernetes, the nodes should be, the pods should be disposable, but then are the nodes disposable and is the cluster themselves disposable? Because or else you end up with this gigantic cluster that by the time it's up, nobody really understands how the cluster is actually being set up. Right. And
to me, being the old guy and, saying that to two old guys, but rolling this all the way back to the day when we used to have SANs and deal with, a Brocade fabric infrastructure and deal with VMs that would sit on top of that. And then you deal with network switches and blade switches that would have to sit on top of that. As we start looking at resilience and we start trying to understand what security is, and I say this because it feels right to me, and push back, please, if you think I'm wrong, and like you would never, but still, the concept being that one of the things that was always really hard was to understand the impact of all of the pieces parts that went into the whole thing that you were building. And we used to have to deal with, this is my backplane, and my backplane is going to support 20 gigs. And if we have a 20 gig backplane, that means that I can sacrifice 10 gigs for network and 10 gigs for storage. And then all of these things start coming in, and it feels like we're back to almost the exact same thing with Kubernetes, where I've got a Kubernetes cluster, and now I've got to figure out what are the actual resources that I've got the ability to begin to architect with. And if I start to build out an application that goes over those resource bounds, then it doesn't really matter anymore.
Yeah, I think there's a few things from my perspective. What I see these days is that obviously Kubernetes has a layer of abstraction, but people do not intimately understand, because you have a number of layers. You have the whole container security, you have container networking security, and then you have obviously hosts supporting the container security. So people do not understand that, how do you apply security context at the container level? Then you go into something like Open Policy Agent, AppArm, or, how do you secure inter-container communication? And then you go into runtime security, something like Falco deployments. There is a lack of knowledge and understanding, because most of the containers building is done either via DevOps or developers themselves. So having, we discussed in previous sessions, how we can build those security reusable blocks. So how we can whitelist a number of container images that has specific security solutions already built in. So you say, just use this. There's a big disconnect, I think, especially when you start leveraging things like, AKS. If you run a production cluster, you get obviously Microsoft image. That's quite secure. But then if you run the dev clusters, you use all sorts of images, and there's obviously riddled with vulnerabilities. How do you address the change between the development cluster and production? Because obviously people testing code in various environments, but if they don't match,
but that's the beauty.
But
that's the beauty of small clusters. See, the beauty of small clusters is that you can run them locally in that, so you have the same cluster throughout, right? I always felt that the only difference between local pre-prod, so local dev, QA, pre-prod, prod, the only difference should be scale, right?
And
literally the only difference should
that's
be,
why I'm pushing back to the resource question, though, frankly, because as you start looking at deploying into Azure, you look at deploying into a cloud provider, take your pick of who, all of a sudden you've deployed to 2 data centers, and those data centers might be 100 miles, 150 miles apart. So now, as we look at, if we're looking at security from the vulnerability question that you just brought up, or the question generally that Marius just talked about, where we start looking at the images and all the other pieces that go into your Kubernetes cluster, what does it become? Does it become possible for me to evaluate network availability, latency, things that I normally would have looked at in a networking implementation for a larger enterprise? Not really.
Well, see, this is the thing. If you have smaller clusters, right, you can simulate all of that, because, and by the way, smaller could be 2, 3, 4, 5 nodes. Right? Because the cluster, or the cluster of clusters, right, that environment is the app, right? So the thing about that, for example, that particular example, is that if you have, for example, if you can spin up your environments, you can now run your simulations, right? You can say, okay, now give me this traffic, now do this. So what was very interesting is that we were able to build very focused testing tools, again, using Kubernetes, right? Actually using Lambda functions actually was really cool to scale up, that could generate an insane amount of traffic, but we were able to test. And so what we found? We found that check this out, right? There was a moment where I was deploying the same Kubernetes. Remember, this is one node per, so but each EC2 instance is a Kubernetes node, each one, right? Each EC2 instance is a Kubernetes node. We did this test where I was running, I think it was about 150 EC2 instances. So I had 150 clusters, right? Across, I think it was 5 data centers. And then you had 15, right? Basically, so because I got to the point, I built a command line. It was very scary, right? Because I had a command line. I was like, spin this up. How many regions, how many pods, how many clusters, how many EC2 instances per image? And it was the same image everywhere, right? We will run it. You know what happened after a while? We start to detect wild inconsistencies in AWS infrastructure, right? So
Cool.
you would have literally the same request sent to 150 instances, right?
Mhm.
And every now and then, and we will keep turning the volume up, right? So we keep finding the point where they were really, really, really hot, right? And there was instances that were fine all the time. There was instances that had a wobble, and there was instances that had fucking literally heart attacks, right? And then when I realized, and I remember chatting to the AWS guys on it, it was like, yeah, because it depends on the neighbors. But think about it, like
Well,
it means
it's
that
neighbors and a whole bunch of other
a whole bunch
infrastructure
of other
that goes
shit,
along
right?
with it. Yeah.
Yeah, but think about what that means. It means that we had to add code to our clusters to be aware of your environment. So even if you think you have 20 gigs, you might not have 20 gigs.
And that's exactly what I was getting at, was
But
that
try
if you
debugging
haven't
that.
planned the resource plan out right.
But no, but this is the difference. It's not even planning. Is your cluster has to adapt itself. So we had a mode where, and the beauty of this architecture is you put load balancers in front, and you have, and you know what was the solution? Actually, eventually the solution was kill it. Literally, we got to the point where once the health checks got to a point, reduce the traffic, so take it off from the load balancer, let it die off, and kill it. Because, and even the AWS guy says, yeah, that's the better way. Because if you start a new one, you go into a different location, right?
Yeah, and that's the point, is that in many cases, really what you want to do is set up this setup where you're looking at multiple points in your application. And if there's a particular instance that's not working correctly, you need to know. And that might be just setting up a simple, I mean, I've done it before with pings. If you can't ping X, or you can't get an HTTP response from, just kill it.
Yeah.
Be done.
Yeah, but try doing that at node level, and it's very hard.
It's hard.
Right? Yeah. That's why the smaller, again, the cluster. And then for me, the solution here was to actually create clusters of clusters, even app, because then you can say, what are all the resources? See, you know what I think?
But then I'm going to push back and say, at what point have you gone too far? At what point have we abstracted to the point of just the silly? Would it have been easier to just use, I'm going to say Elastic Beanstalk, but
well, there's a point where lambdas might be perfectly fine.
Yeah.
Right. But that's a very valid point. There's a point where, in a way, there should be an evolution, right? There's a point where lambdas are not good enough or too expensive, right? Then that's when you go containers. And there's a point where containers gets too big. That's where you go to the cluster. And the moment where, in a way, I think it's almost like we try to optimize something that should not be optimized, which is this idea that, oh, I have one cluster, I have 5 clusters. Well, usually people don't have 5 clusters, they have one big fuck off one and a couple of redundancy ones, right? At least that's what I've seen a lot.
And
right?
I think that's where
that's very risky, right? It's very risky, because it means every time you push a new update, you risk blowing up your entire cluster.
I think Marius has got a point here, but after Marius goes, then I've got a point back to you. So
I think that's where, that's where you mentioned kind of, I think if you discussing Kubernetes deployments, obviously it comes down to cost, but you need to get to the point where you can ultimately run a proper chaos shop where you can inject faults continuously to evaluate where the problems occur. So being proactivity then instead of reactive, and then you can plan, because obviously you foresee particular growth, whether it's traffic, customer, acquisition and things like that, where you can potentially get ahead of the curve where the problems might occur, and that will feed into your design questions essentially.
Yep. And I think you're hitting exactly what I was going to hit, Marius, and apologies, I'm a little under the weather today, but I completely agree with you. This is security and resilience by design. You can't just pretend that it's going to be okay because you're using Kubernetes. And building your application so that it is aware of both the infrastructure that it's on and, frankly, the limits of the infrastructure that it's on. And if it realizes that, you know what, I really can't get to this machine over here, maybe it's time to spin up another alternative because I'm not working right.
Yeah. But if you look, I think the bit I'd like to expand more in terms of security is, I always find that the less moving parts, the better, right? So if you take that to an extreme, and this is where I feel there's a potential that we haven't fully fulfilled here, which is that we should be absolutely brutal, for example, with the size of images, absolutely brutal with what's inside the containers, even what's inside Kubernetes. It's kind of like, it's not because the normal Kubernetes deployment has these features that you want it. Like, it's almost like, what is the minimal viable, deployments that you can do? But here's the problem. this is the thing that I don't think you experience until you really experience Kubernetes as a disposable unit, is that if you can spin up Kubernetes clusters super easy, and by the way, at the moment, last time I checked, AWS clusters or Azure clusters still take like minutes. And I'm like, what the hell are they doing? Playing chess, right? Like, well, the Kubernetes cluster should start, right? So if your cluster doesn't just start super quickly, you can't experiment, right? Think about it. Every experiment takes 10 minutes, 2 hours, whatever, and you can't do that. So you can't lock things down because you need the interactivity of the experimentation.
Let's be honest. I mean, it's expensive to experiment that way sometimes. Like, just in full disclosure, I have 4 clusters in my house right now.
Yeah.
So, I mean, it is what it is, and it's just what I'm running here at home, and that's fun, and I'm enjoying it. There's no real reason for me to run Kubernetes in the house. I mean, come on, that's just silly. But at the same time,
that was good. You know, it adds value, right? You know, you can experiment, right?
But back to your point, and to the point that in general, like, I think there's some point at which we're going to have to start looking at what is the minimum viable container that we can actually run.
Yeah.
So it's become more and more concerning to me as we've talked about, like, different software supply chain attacks and seeing different reality. As we look at, you know, network security, that's fine. But the reality is, if my implementation, if my image is so bloated with, I've got a full installation of, you know, take your pick of OS, and then I'm running my little app inside of it.
Yeah. So I really like those light images. Right.
Well, the hardened images, yeah. I think we need to get to the point where we just automatically run a script at the end of it, and it looks at it and goes, "Oh, I see. You're just using these 3 things," and rips out.
So here I'm going to bring the good old these days Gen AI, right, and LLMs. That's another area where I think it can add crazy value. Imagine a world where we take an image, we feed it to a Gen AI, you know, that's been tweaked, an agent that's been tweaked for understanding that, and we say start removing things. Right.
Well, I don't even know if we need Gen AI to do it. I mean, can't we just do it with a basic process call and like figure out what's running? And
no, because you need context. Okay, I think that you could do it like that.
Yeah.
But that's very complex, very fast, because I think you need a level of reasoning. You need a level of logic that is very hard to code. And I could see how having an LLM that has a series of prompts, and maybe not one, maybe 2, 3, 4, 5 LLMs working together, I can see how that's much more usable and practical than trying to code. Because to be honest, I think people have tried to do it. The problem is you need a degree of context. You need a degree of understanding. And even once the objective, that is very hard to code.
Yeah, I think you can leverage Gen AI in a few things, because as we discussed in the beginning, like, you know, things like mapping of the traffic between, you know, the specific containers. So Gen AI potentially could help you build a map, you know, who needs to talk with what. But I think, you know, as Nathan mentioned, you know, I think we need to take up a notch, because the one thing that is always missed, yes, we doing agile sort of deployment and agile, you know, code changes and all of that, but drift analysis, it's one sort area that's always neglected.
What do you mean,
and I think
drift?
leveraging something like Open Policy Agent, where we can define how our, you know, production clusters should look like, to make sure that we are alerted from, you know, people A, making mistakes, and B, just, you know, going berserk on some new innovation that they decided, just deploy and see what happens.
But even if it's just a basic, like, I'm using this open source library, and today it changed from A to, you know, 8.1, and all of a sudden it's pulling in a bunch of other stuff. I mean, just the drift associated with that alone is significant, and not looking at the packages, not really understanding what the packages do, or not understanding some of the impact of those subs is going to be an issue. And it's great to say I've got my SBOM and yay, but like, if you're not actually running it if you're not getting an SBOM that actually includes all of these other things, I'm not sure it really matters much.
It's not even that. Like, I think like what you just mentioned is it's a very important area to address. I think loads of developers do not understand even how to build a secure image.
Well,
what's the best practice in terms of building as minimal image as possible, making sure that it doesn't run unnecessary updates, and just pulls the correct, you know,
the simplistic,
the simplistic correct packages that it only needs to run. And that's you know, that's another area where supply chain is a massive task at hand.
Yeah. It's true.
But you see, and that is an area that I think the new generation or the next generation of bots can make a massive difference, right? Because understanding that context is really, really, really hard. And I feel that, being able to explain the intent, like you just said, imagine, see, even, Nathan, take that simple case. You want to be able to describe, this is a mission critical system. It has these properties. I expect this. I expect this blast radius. I expect that. That is something that we can now start to describe. To try to codify that will be crazy difficult. We can describe that behavior. And then we say, by the way, here's a Kubernetes config file. By the way, here's a Helm chart. Is that Helm chart going to break this particular situation? Like, I've fed TCP dumps, even like git commit. Have you fed a git commit to ChatGPT?
No, actually, I haven't ever tried that.
Dude, it's freaking awesome.
Should.
Look,
okay.
So we're now using it to create change requests, right? And then to describe pull requests. So imagine a flow. And you know what I found really interesting is, as a developer, I actually enjoy reading that, because I found that it described nicely what I was doing as a developer. And sometimes I go, oh shit, yeah, I missed that one. Actually, I did change that in the code. But also, even when you make a little mistake, it doesn't matter. You tweak it, right? So it's still your text. It's still your pull request. It's still your commit. But the quality, and you can also say, give me a business analysis, give me a technical analysis, give me, in fact, can you say, give me a security analysis of that? So imagine that world where, imagine that for a Helm chart. Imagine having a Helm chart that describes that.
Now, time out before we tell everybody that's ever going to watch this video to go out and find yourself an LLM and ask it to look at your Git commit and your code. Please make sure you've talked to your CISO, looked at your internal governance policies, and made sure that you're allowed to do this, so that your copy of information doesn't accidentally fall into the wrong hands.
Yeah.
No intellectual property in there.
Have pet open source projects that you can do that. Solves that problem.
Sorry.
No, it's good. Exactly. Yes. No, don't go and paste your confidential
disclaimer.
Into ChatGPT.
Sorry.
Well, actually,
being a CISO, I feel like I need to say this now. Sorry.
Well, but to be honest, I think we can already say that these days you really should have private models, right? Look, Azure has pushed it. Bedrock.
It's a great thing to say, but man, the private models aren't nearly as good as the public ones, and it's always going to be that type of thing.
Yeah. Well, Azure OpenAI is not that bad. I think it's traveling really close. Yes, ChatGPT is, okay. The later, by the way, have you tried the model one, where you can upload an image?
No, I have not yet.
Dude, it's Simon Worley was like, that's the game changer. I think it was already a game changer before that, but I agree that that's a game changer. Like, dude, you can now do an architecture diagram, go to ChatGPT and it says,
give me an idea.
Transcribe this. Give me a flow chart. Give me this in Plan to ML. Give me this in thing. Right? It is pretty freaking cool. Right?
I'll have to take a look.
It's a big game changer. Right? But I think if the point we were just talking, which is how do you create the small possible Kubernetes cluster, for example, or a small possible image? I think in the past that was really difficult to do because you couldn't explain intent.
Yeah.
And I think we're going to be able to start describing intent, right? And in fact, you'll be able to start describe even an image. Imagine being able to build an image where you say, I want this image to be unusable apart from port 80 and apart from Node or Python or Go or this binary. And that's it. That's all you should have. You should have what is the minimal viable Linux environment that is required. Start deleting everything else. Right? In fact, experiment, do chaos on top of it, run your tests, and then start deleting stuff that you don't think could be usable, right? But imagine doing that in a way that we can describe it, right? And imagine, in fact, imagine that in the next generation of an LLM that actually understands the Linux kernel.
Well, yeah, I was going to say, I mean, go so far as to say that I've done my Git push, and we've gone through the whole thing at this point, and instead of the build that we would normally do, it actually goes over to the LLM. The LLM builds out the image that would be appropriate to what you just asked for. And it's only those things as opposed to everything else. And there's really no interaction whatsoever. I mean, none of this stuff is rocket science as such.
So the only thing I would say there, the caveat I would add, and I think this is where I think some people, are flipping. So I don't think the LLM builds it. I think the LLM analyzes, creates the pull requests,
I was going to say,
propose a modification, and then there's a build pipeline that was.
I would go so far as to the hardening scripts almost, and I would agree with you.
Yeah,
I think
yeah,
where you're just looking at the hardening scripts, but yeah.
And then the other variable here, which I think discussion sometimes is that, like, for example, even in this workflow, if you think about it, I'm not saying that you let an LLM loose. It does its magic and then come back tomorrow and go, hey, here's your build. What I'm saying is that the LLM is going to have a conversation of commits, pull requests, changes, etc., that is completely logged, is completely justified, that we can then go back and analyze. And Mario, this is where I'm tying up almost all the sessions. This is where, when you then look at our situation awareness and instance response, we should be able to go back and going, I missed this bit. Ooh, this was not supposed to be there. And the big paradigm shift for me, right? Let me show you this image, right? Because I did a presentation on what's it called? On why everything should be a cyber expert. But there's one picture that I showed in there, right? That for me was the big game changer, which is this. Can you guys see? Can you see my screen? So wait.
Yeah.
So that one, why everyone needs to be an AI expert. So I presented this, but the screen I really want to show is this one here. Have you seen this image?
No.
Have you seen this one? Okay, this was the one. Ironically, it was a visual, but it was the one that made me really understand the power of generative. Is that the square in the middle is the original painting. The rest was created by Gen AI. The same way that, for example, here you got the Mona Lisa, and then you got the expansion. You got Nirvana, and you got expansion. You got, for fun, Metallica on a cake.
I think the key point is what we're talking about is, and what you mentioned is, having all of the deployment and all of the builds and all of it in LLM, because what we discussed, I think, and the main topic today is, we don't have enough context normally to make right decisions.
Well, and roll back to the Metallica image, to Marius's point here, roll back to the Metallica image there. So neither does, like, to Marius's point, Metallica is not right. That is not a cake. If the LLM gets the wrong idea here, Marius is that's going to look bad, right?
Yeah, it will. But you know what the power of this is? Is that, let's say even this happened, right? Okay, so let's take the analogy, right? This happens, somebody builds a cake, right? With the Metallica logo, right? In the past, the cost of creating that in a different scenario will be massive, right? In fact, it will be as big, if not more, than creating the cake and that visual, right? The power of the way the generative works is that cake is one of billions that you could have done based on the input that we provide. So when we come around and maybe on an instant we discovered, oh, it's a cake, it should not be a cake, you can go back and you can now modify the prompt and say, actually, it's like this, like this, like this, like this, right? So that for me is the big paradigm shift. The big paradigm shift is that what the generative bit does, it means the creation is now cheap, or the modification based on the prompt that we can then test and we can validate and we can diff, we can do all that stuff.
That assumes a human catches it, though. I mean, that's the issue right there. Like, to Marius's point, and I apologize, Marius, I feel like I cut you off there pretty hard. Is that where you were headed?
No, I was, that exactly, because the point is, as you say, yes, it's cheap to experiment, but if you push the cake into production, what's the outcome? My point is that, yes, we can use LLM, but as long as we fed enough context and we used it in the background while we did, a number of commits, number of builds, and then they build the context of what we need from security, what developers need, what's the business goals, and then we only start slowly saying, oh, it has enough data, it has enough context to know where it should be driving towards. Because if you just ask to build, say today, I just plug it in and say, build me a secure image, it's going to build you a cake.
Yeah, but see, here's where I would draw the line today. See, I would argue today, you don't want the LLM to create the cake, right? You don't want the LLM to create the output that ends up being in production. You want to use the LLM to aid the human, to augment the visibility, to augment the understanding of what's there. And that's a very different proposition. And that's where hallucinations become less of a problem, because there's enough checks and balances in the system. So if I ask an LLM to say, here's a bit of code and analyze this for me, you know, whoever wrote that or whoever's in this loop can say, that's right, that's wrong, right? And then even if you do analysis on top of it, eventually you're going to figure out, well, that analysis was wrong, so you can modify it.
Yeah,
And-
if you've got checks and balances in place, yes, I understand.
that's the point.
But what
The
we
point is
discussed
to-
earlier, you said you don't want the LLM to build, you want the pipeline to build. But if it just goes automatically by the pipeline build into the production, then obviously we have.
Yeah, but we shouldn't allow that. And by the way, that's already happening today
Well-
anyway. How much commit today happens on your pipelines that's nobody really checked properly, right? Like if you have the dev team shipping 20, 30, 50, 100 times a day, how many of those commits have been looked at from the security team?
Yeah.
Even if you have static analysis and dynamic analysis, right? The percentage, even if you have, is still, that is already happening today, right? We're already shipping to production code. But I'm not saying we should allow the LLMs to do that, even with automation. I'm saying what we should be using them is to in the steps in the middle to allow us to understand context.
Yeah.
And I think as we go there and we push back to the original topic that we were supposed to be talking about, which is networking in Kubernetes, if we can look at these things that actually build out the build scripts for us, if you will, that will allow us to build out the cluster that we're going to get in the end and deploy the application, it would be really great if we could then go ahead and and could you give me a network security mapping or detection system that would allow me to see things that are not supposed to
Can you write
happen?
the rules for me? Can you give me the error rules? Can you give me the,
I mean,
like, for example,
it's basically IP tables. Why is this a hard thing? I mean, like, just
because until you have an LLM, the cost of engineering was great. Like, put it this way, if
I
give you a
understand that.
brief-
What I'm saying is, like, as you talk to the LLM, this is just IP tables. Like, just
It is, but the level of complexity is too high. If I go to you and say, can you take your Helm charts, your live processors, your execution logs, your IP tables, your flow data, or your analysis of it, can you mash it up and give me a view and inconsistencies? You know, you turn around and going, great, give me $2 to $5 million of development and I build it for you. And even what you build might be highly freaking locked in and customized to that question. With an LLM, you can now look at that problem very differently.
Mm-hmm.
You can look at creating abstraction layers at every point and then connecting the dots and connecting the intent. And I think there's going to be a huge amount of innovation there. Because we now can ask these questions in ways. I think we can now start to ask questions, say, can you start to output data in ways that are easy to understand? Can you start to output intent from your information? Which we're not about the vulnerabilities, we're going to have to deal with it, etc. But at least that can be checked. And at least we can start to learn to trust or not to trust some of these analyses. And you know, at that moment in time, the smaller the LLM, the less scope it has, the better it will be. Like I want an LLM that only understands IP tables. That's it. All it does. That. I want an LLM that only understands network diagrams, blah, 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 has a very small subset, doesn't need to write poetry, doesn't need to know about NIST, doesn't need to know all that shit, just needs to have enough context that we can then prove with behavior, with analysis, with battle hardened, and with with evidence eventually, that it does that really, really, really well.
I totally agree with the thought. Please go ahead.
Question, Nathan. I was just going to ask I wanted to pick your brains a bit. So we discussed about, correct image builds, some things like App Armor, Open Policy Agent, and things like that, how we, build secure clusters from the get-go. What's your vision about, people might miss or might not know how to do these things. So instead they say, oh, let's plug in, runtime protection, something like Sysdig, or whatever, or Datadog or any other sort of company that uses runtime protection, and just see how they can help secure us Kubernetes from the other angle. What's your view between the two thoughts of school?
I would love to. So a long time ago in a galaxy far, far away, I worked at AWS and we released some really interesting stuff in Lambda. And a company that no longer exists, I believe it got acquired, And a friend over in England actually wrote a script that would strip everything out of the Lambda container that you didn't need. And it would just automatically, like, you would push your script, it would run, it would strip everything out of the Lambda container that you didn't need, and it would remove all of the AWS permissions that it didn't need to have. And it was man, it was cool.
That's cool. Where's that feature?
What?
Where's that feature in AWS? I want it.
I don't know. I stopped working at AWS a while ago. I apologize. But it was one of the coolest things that I've seen Dave do in a long time. And it was really legitimately helpful. And I think what I'd like to see to answer the question in sort of a roundabout way, Marius, is more this concept of, and kind of going all the way back to in days of yore and yonder, when we used to have to like build out a SAN and plan out what the backplane was going to do and understand all of the implications for all of the different drive speeds and how the fiber channel was going to interact with all of these things. I think there's something to be said for, it would be really nice if we could get Kubernetes to just load up and go, hey, you're using this and you don't need that.
Yeah.
And automatically strip it out. I don't care who it is, honestly. It'd be really nice if we could just accept the fact that realistically, we don't need 90% of the container we just uploaded. And even if I can just run a function that spends a day running it through a significant number of different interactions on the API layer, and then gives me a list of, hey, these are the things you actually need versus these are the things you actually have.
Yeah.
It doesn't strike me like it's that much of a walk to do it. I think Netflix had something called Goat for a while, didn't they? That did a very similar sort of a thing. And it's one of those things where, like, from a security geek point of view, it would be really nice to be able to build out my hardening scripts that way, as opposed to having to like hand jam the whole thing.
Dinis, you ready to build a company? We just got an idea.
Yeah, I think that's, I feel it starts to be doable now, right? I
think we're on the edge.
Right?
Yeah, I think we're right at the precipice of you could do that.
So here's an interesting question. That's why one of the slides I have on that presentation is that everybody should either be panicked, be very excited, or a lot of people are ignoring it, right? But what I think is interesting in the next couple of years is going to be which industry is going to innovate more. Is it the security industry, or, for example, the developer industry? Because, for example, what you described could be done by a dev tool, or could be done by a security tool. We don't care. We just want one of them to do it, right? I
disagree. I completely and utterly disagree.
What do you mean?
I think security is smoke. I think as a security geek, I kid you not, I think security is just development that we've tried to make special and different. And the reality is it's development.
We live on the outskirts of inefficiency of other industries.
I really think that we should just embrace the fact that security is development, and it should be a development tool, and that's just good development.
Yeah.
Sure.
I agree. Oh yeah, no, I agree with that. No, I'm saying is that which side is going to innovate? Are you going to do this from a security angle?
I would hope that we do it from a
development, or you do it from a development angle, where that
I would hope we do it from a development angle and we grow towards security.
I agree.
If we do it from development angle, it's more chances to succeed, because if it will be done from security angle, the marketing will be, oh, we make your Kubernetes 100% secure, we 100% protect from breaches and all that, and it will become a snake oil and nobody's going to use it.
Yeah, but what we should be doing in security is saying we make your product faster, resilient. It's like a read-only container is super resilient, right? Like the ability to diff the containers, the ability to, like I said, measure that delta is the thing about security is that we do have a bit of a different perspective. In fact, I argue that when I was a CTO, I argue that my understanding of what was possible is very different. Like the Kubernetes model that I described to you guys, I arrived there from both. I was CISO and CTO. I arrived there from two hats. I wanted a small possible container from a security point of view, small possible development. I want to lock it down easily, and I want the small possible piece from engineering point of view, right? I had to argue with Kubernetes experts because they said that's not how Kubernetes is supposed to work. Literally, they just didn't have the mental bandwidth to take a little step back and going, okay, maybe that's what I was designed. Yes, you master and slave are not in the same box. But maybe that's not a bad thing, right? But it was funny. Cool.
That's why I go
Alright.
back to the discussion about like forever ago when we used to have to think about all those little pieces.
Yeah.
You were going to build out a data center and you had to know, where do all
Yeah.
these things go?
And now it should be disposable, right? And our
And
clusters
now it's all
should be
this
disposable.
big, and the data center is, literally
Yeah,
in
but
the
our clusters are massive.
Intel NUC in my basement.
Yeah, but our clusters are massive at the moment.
They are. Yeah,
Right. So they're pets.
they should
They
not
are
be.
pets, but they are. When was
But
last
they
time
shouldn't.
when was last time they got rebuilt? When was last time? Can you go and delete it all
Let's see. Last time they got rebuilt
from scratch?
from scratch. Let me check. Hang on. They've been up for 1 day.
Good. What about your production in your company? The production ones in
Well,
your
that's a
company.
different question. I'm
Yeah,
not gonna
that's
answer
the
those
one.
questions.
Yeah,
That's
but
none of my business. I don't ask those questions right now.
all
No,
right, guys.
it's all good.
Cool. I think it's good session. I think any final remarks, comments on this?
I would say that Kubernetes security is becoming more and more prominent question that needs addressing, and I think what we just discussed in terms of it needs more. We need more fresh ideas, looking at different angles and stepping away from what is needed. I think sometimes we do security and development through not necessarily obscurity, but we make it more complicated than it has to be.
Oh yeah.
And it becomes sort of a barrier to entry where we border ourselves and saying, oh, we do this very, very complicated things that nobody could understand. Therefore, we lack innovation and perspective from different, angles. I think that's where we need to,
Well, and we get into diversity there too. I mean, not that we don't have 3 white guys talking on this, but at the same point, like diversity of thought and diversity in general in doing this type of thing is desperately important, because if you don't do that, the only thing you come up with is the exact same idea over and over and over.
And I think there's a couple of startups we already
Yeah.
described on this presentation, right? I do feel that the Gen AI is the game changer here. It brings capabilities that before were just too complex to do, but not to make the cake, to analyze on the way to the output. Cool. Brilliant, guys.
Thank you.
See you around.
Later.